You're going to spend the whole next at least 3 or 4 months taking derivatives, practicing taking derivatives. So let's have our first practice. You've written down this expression for the derivative of f of x, which is f prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h, the difference quotient of f. So here's a function, y equals, or f of x equals 3x plus 2. Let's practice finding the derivative. So I'm going to write down my expression for the derivative. I'm going to substitute into the function. So my function takes x and multiplies it by 3, then adds 2. So if I need to put x plus h into that function, I'm going to take x plus h and multiply it by 3, and then add 2. And I'm going to subtract just regular old f of x. After that subtraction sign, you have to remember that we're going to need to distribute the subtraction. So that whole second piece, my f of x, that 3x plus 2, I put inside brackets. So remember to distribute the subtraction. So I can just distribute and do some canceling. This 3x and this 2, cancel with that 3x and that 2. I end up with 3h over h. I can cancel the h's. Then it's safe to plug in 0 for h, and I just get the limit is 3. Did that surprise you? What did we say a derivative is? It's a function that gives the slope of the original function at any point. So think about this function we started with. F of x equals 3x plus 2. That's y equals mx plus b. That's the equation of a line with slope 3 and y-intercept 2. What's the slope of that function at any x value? Well, the slope of a line never changes, so the slope of this line is 3. So we got a derivative that says no matter what x you care about, the slope at that x value is 3. So now try this one. What if I want to find the derivative, what if I want to find f prime of x, and f of x is 1 over x? This is similar to the example we did at the beginning of the first video. So I'm going to take the limit as h approaches 0 of f of x plus h minus f of x all over h. I hope you recognize now that you need to have this expression memorized, and you have to be able to just throw it down on the paper and start plugging things in so you can find derivatives of functions. If I need to put x plus h into the f function, it's going to be 1 over x plus h minus 1 over x all over h. I'm going to get a common denominator, that same process we went through. You can see here, when I distributed that subtraction, notice that that would be the place that students sometimes have a mistake in their algebra. So make sure that that subtraction is getting distributed. X minus h, no, x minus h, which results in negative h. Now I'm going to rewrite as multiplication by the reciprocal of the denominator. My h's cancel. And when I finally get down here, it's safe now to plug in 0 for h because I won't make a 0 in my denominator anymore. So it's going to be negative 1 over x times x, which makes negative 1x squared. That means at any point on the function 1 over x, if I picked any x value, I could plug that x value into this function, and I'd get a number that tells me the slope of the original curve, f of x is 1 over x, at that point. So here's another example. It doesn't happen to be in your notes paper. I could use that, instead of giving you a function f of x, I could just call it y. So here's a parabola, y equals x squared minus 3. If I asked you to find y prime, this is the same process. You're going to take the limit as h approaches 0 of essentially f of x plus h minus f of x all over h. So what happens to x? X gets squared and then has 3 subtracted. So I'm going to start with x plus h, make sure it gets squared and then has 3 subtracted. I'm going to use subtraction. This is me subtracting f of x, and notice f of x goes in parentheses so the subtraction gets distributed. We could FOIL out x plus h squared. You can see that happened here. My minus 3 is going to cancel with my minus negative 3, and my x squared and my negative x squared are going to cancel. So I'm going to have 2xh plus h squared all over h. You can factor an h out of all of that. what I'm going to end up with is the limit as h goes to 0 of 2x plus h. Now, since I had the h already canceled out, I won't have a 0 in my denominator problem. I can plug in 0 for h, and I have here y prime is 2x. So just think a little bit about what that means. What's the slope of a function? So slope is how steep a function is. And I could think about, look at this parabola. Here, the parabola is going downhill, right? And we know that lines that go downhill from left to right have a negative slope. The parabola then, after the place where x equals 0, can we say starts to go uphill? Technically the word is increasing. Starts to go uphill, so the slope must be positive. So watch this. Here we've graphed y prime equals 2x. Notice that this function is negative whenever the original graph was going downhill. This function is positive wherever the original function was going uphill.